Hey guys, it's Tensor. Welcome back to the Beginner's Guide to Dart. Today we're going to be looking at generics, we'll look at enumerations, we're also going to look at exceptions and exception handling, and we're going to be looking at factory constructors and singletons. Throughout this tutorial we've looked at collections, and collections have what are called parameterized types. Those are the types that are inside of these angle brackets. So this list, for instance, is a list of string type. And then this map has key values which are integer type and then the values which are string type. These parameterized types come from generics. Generics are a way of enabling code to work with an arbitrary type. Instead of specifying the type for the method, property, or instance variable, or on the return, we declare that the code will work with a user-specified type, and then when we actually invoke the method or create the instance variable, we have to fill in a type. So when we're creating a list here, we fill in that the list is going to be filled with strings. And of course you can put in any type here because list uses a generic type. Let's create a class that uses a generic type. So here we've defined a class called printItems, and we're using a generic type called t. Inside of this class we have a field which is of type integers, which will be called times, and then we also have a field which is called printItem, which will be of type t. The class has a normal constructor here. Now let's create a method which will loop from 0 to our times integer, and then it will just print out our printed item that many times. So now when we create the class, we need to specify the generic type using our parameterized type notation. So I can write here printed items of type string, and then the type will expect a string for the second argument of the constructor. And of course you can use other types inside of these angle brackets. So here I can say printed items of type double, and then I can pass in that I want to print out 10.2 6 times. And if we want to, we can even pass in the printed items type to our printed items class. So here I'm saying let's create a printed items class where this field is of type printed items, and we want to print out this field 3 times, and I'm just using the string one that we created up here. As you can see, if we go ahead and run our code, we get hi 5 times, then we get our 10.2 6 times, and then we get the instance of printed items string type 3 times. Now another interesting thing that you can do with generics is have the generic type actually extend another type. So if I want to make it so that this generic type will extend the number type, then I can just say t extends num, and you can see here now the string and the printed items type both throw back an error because they don't extend the num type. So now I've made it so that this type t needs to be either a double, an integer, or a number type. And the inheritance of these types works like any other extends keyword inside of Dart. So when you inherit from a type, you need to make sure that the type that you're trying to use in the generic actually inherits from that type. You can also use generics inside of functions and methods. Here we've got a function called generic, which returns a string type. This generic type takes in 2 generic types, one type t and then one type s, and then we just return a string representation with these 2 types inside of it. When I call the function, if I want to, I can go ahead and use the parameterized type to specify the types that I'm going to put into the arguments, or I can completely just remove this and then just put in the arguments, and the virtual machine will know what types are being put in there. We can also have the function or method return a generic type. So if I want this to return type t, I can just make it so that it will return type t, and of course, since we don't really know what type t is, I'm going to have it just return a. Now notice if I try to say like add these 2 together, it's not going to work, and that's because both t and s are nondescript types, and they do not implement the plus operator. So they only really inherit from the main object type unless we specify otherwise. If I want the plus sign operator to work, I can have both T and S extend the number type. That way we can then add these two numbers together. And now of course we can go ahead and just put in various types of numbers, and this should work properly. So we can put in an integer or a double or a number type. The main advantage of using generics is for code reuse. Just having the ability to write one class or one function that can be used for multiple different types can be very useful, especially when you're working with objects and you're working with fairly complex objects at that. Let's take a look at enums. So here I've created what's called an enumerated type called status, and status only has two types inside of it. So status can either be stopped or it can be running. In our print items class, I've extended it and added a field for a status type. And then I have a little if statement which checks to see the status index. And if this status index is equal to 1, then we'll run our little for loop and we'll print out the printed item. Otherwise, we'll print out that the item stopped, and we'll print out the status and then the status index. It's important to note that with enumerations, each of the types that you put in here is marked with an integer. So the stopped type is by default at 0 index, and then the running type is by default at 1 index. And then if we added a third type in here called paused, then this would have an index of 3. So because the status type uses an index, we can use an if statement like this to check to see which type we're using. So at the top here, we have stopped, which is 0, running, which is 1, and then paused, which is 2. And then down here, we're checking to see if we have an index of 1, meaning our status is equal to status.running. So when we instantiate this class, we'll only print out using the for loop if we have status running being passed to the class. So for the first print items integer, we're passing in 10, 50, and status stopped. So this will not enter the for loop. Then we also have printed item string, which we're passing in 20, a string that says hi there, and then status running. This will print out hi there 20 times. And then we're also calling printed items inside of printed items. And for this one, we're passing in status stopped, and we're passing in our print items integer and then 2. And of course, this one will not enter into the for loop. So here we get item stopped, status stopped, and then 0. Then we get our 20 hi there's, and then we have another item stopped, status.stopped 0. If I come in here and I change the status stopped to, say, status paused, when I run it, you'll now see that it'll say item stopped, status.paused, and then it'll give us the index of 2. Now you can kind of think of enumerated types a bit like Boolean types. In a Boolean type, you can either have true or false, and you can't have anything else. In a enumerated type, you can make it so that you have a finite amount of types, and the type will either be one or the other. So in this case, we have 3 different types for the status type, and either it's stopped, running, or paused, and it can't be anything else. Now let's take a look at exceptions. So inside of main, I've created an integer called index. I've created a list of string type called names with 4 names inside of it. And then I've created a string called input. And for this example, we're also importing Dart.io. This is a library that will allow us to do input and output. Now the reason why we want this library is so that we can actually read in user input from the console. So down here, I'm printing out enter in an integer, and then I'm saying set input equal to standard in dot read line sync. And what this will do is it will wait for the user to input something into the console and then hit enter. And then it will put that value into the input string type. Let's try to take the input, which we're getting in as a string, parse it as an integer, and then print out a name with the index of the input that's being pushed in here. So if I type in a number, say 1, it'll print out the name Jackie. But if I type in, say, S, we'll get a exception and everything will error out. The specific type of exception that gets thrown when we type in S is what's called a format exception. And then if I put in a number that isn't in the range of the list index, then we get a range error exception. Now if we want to, we can use what's called a try-catch block. What this will do is it will try to run this code, and then if we get an exception, it will catch that exception, bind it to this variable, and then run this block of code down here. So in this case, it will just take the exception and print it out for us. However, Dart gives us a more fleshed out version of the try-catch block called the try-on-finally block. So we know that if we put in a non-integer input, we get back a format exception, and we know if we put in an integer and it's outside of the index, we get back a range error. So we can say on format exception do this block of code, and then on range error do this block of code, and then finally do something at the end. On our format exception, we'll print out that we could not parse the input. Then on the range error, we'll say that the integer was out of the range of the index. And then for the finally statement, we'll just print out that you selected this index out of names.length, which will print out the length of our list. So now if I run our application and I type in, say, 100 for our input, it will say int out of range of index, and it will still print you selected 100 out of 4. If I put in, say, hello for our input, it will say could not parse the input, and it will still print out that you selected null out of 4. Then of course if I put in a appropriate number, we'll get a name out of our list, and then we'll have a printout which will tell us what we inputted. So this try on finally block is very useful because it allows us to handle known exceptions in a way that doesn't crash the rest of the code. So even if we do get an error in the try block, we can still save our application from completely exiting by telling it what to do when we get a specific type of exception. Now, along with the try on finally block and the try catch block, we can create our own exceptions. First, let's create a person class with a string name and an integer age. And then we'll create a class called pub. And the idea here is that we want to check to see if the person is old enough to be inside of the pub. So let's make an exception called toYoungException. And we can use this inside of a method which we'll call checkAge. So here we have a list called drinking, which is a list of person. And then we have our checkAge method where we pass in a person and we check to see if their age is less than 18. And if they are less than 18, then we throw a toYoungException and we pass in a person. Otherwise, we add that person's name to our list. So to create our toYoungException, we just want to implement the base exception type. Then because we're passing in a person, we want to add a field for the person, and then of course add a constructor to our exception. We can add a toString method, which will of course be overridden, and we can then say p.name is toYoung for the pub. Now inside of main, let's go ahead and create our pub, and then we'll try running checkAge on various different people where we pass in a name and then an age. And then if we get it back an exception, we want to catch that exception and then print it out. And then afterwards we'll print out the list of people. As you can see here, we get back Johnny is toYoung for the pub, and then we have 2 instances of person inside of our list. Let's make it so that when we print out our list, it just prints out the names. So we'll add a toString method to our person class. And now when we run it, you can see here, Johnny is toYoung for the pub, but we have Jimmy and Jackie inside of the pub. Keep in mind, in a try block, order of execution is important because as soon as you hit the exception, the block stops running. If I was to take Johnny and put him at the very top up here, then these other two lines will never be executed, and so our list will have no one inside of it. And as predicted, you can see here it says Johnny is too young for the pub, and then our list is completely empty because it didn't run the other two lines of code. Now let's take a look at factory constructors, and we'll also take a look at singletons. So first let's create a class called animal, and the class will have a single property which we'll call type. For the animal class, we'll create what's called a factory constructor using the factory keyword. Now with a factory constructor, we can also create other named constructors. So here I'm creating a private named constructor called animal._type, and it just takes in this.type and then sets it. Now factory constructors are specialized constructors that are used in situations where you don't necessarily want to just create a new instance of the class where the factory constructor is defined. Instead, there may be a situation in which you want to do something different depending on the information that's being passed to the constructor. So for example, if I create two subclasses to the animal class, one called cat and then the other one called dog, and I wire up these two subclasses using the ._type constructor, I can then use the factory constructor to make it so that we can either generate a cat or a dog type. We can just say if the type equals a string of cat, then we'll return an instantiation of a new cat type. Else if we get type equal to dog, then we'll return a dog type. Else, if we don't have cat or dog, then we'll just call animal._type and we'll pass in the type. Up in our main function, I'm going to instantiate three animal classes using our factory constructor. I'm going to pass in dog for the first one, cat for the second one, and then for the third one I'll pass in rabbit. Then we can check to see what type each of these animal classes is by just checking if it is a dog, a cat, or an animal. So this will return true if this is a dog, this will return true if this is a cat, and this will return true if this is an animal. And of course we get back three different true calls. We can also switch around these is statements, so I'm checking to see if A is a cat, if B is a dog, and if C is a dog, and predictably we of course get three falses. This type of factory constructor can be very useful in very specific cases, but the real power of the factory constructor is to create what's called a singleton object. A singleton object is an object where you can only instantiate one instance of that object. And if we go to instantiate that object again, it will just grab that original instance again. Let's go ahead and create a class here called item. Inside of the item class, we're going to have a field which will be an item type, and this is where we'll actually hold the singleton for this class's object type. And of course, this is why we're using the static keyword. I've also added another property here called state, and we want this property so we can see how the state will change over all of our objects. To make this work properly, let's create a private constructor called _internal, and then we'll create our factory constructor, and we'll check to see if the property item is equal to null. And if it is equal to null, then we want to return item.item equals item.internal. So this will instantiate the item class when we first call it, but if it's not null, then we can just go ahead and return the static item property from here just by calling return item.item. Now we also want to set up our state string. So when we call to the factory constructor, we'll pass in a string called state, and then what we'll do is we'll just call the internal constructor here, then use the cascade operator to set the state field equal to the state string that we're passing in here, and then when we return the item.item, we'll again reset the state field and set it equal to state. Because I'm using the cascade operator, I do not have to use the this keyword. Dart will know that this state is referring to this state, and that this state is referring to this state. Now up in our main class, let's create 3 different item objects, except because this item class is a singleton, all of these item objects will be referring to the same object. And we can show this off by printing out item equal to item 2, then item 2 equal to item 3, and then of course we can print out the state of each of our items. And if these were each individual instances of the item class, then each of them would have a different state. But if they are all the same object, then they all should have the last string that we passed to the last constructor. And as you can see here, we get back true for both of our conditionals, and then the state for all 3 of our objects is just the different state string, which means that they're all pointing towards the same object. Alright guys, well I hope you enjoyed this tutorial. If you did, feel free to like and subscribe. If you have any questions or comments, feel free to leave them in the box below. And if you dislike this video, then by all means downvote it as much as you like. Have a good night.